SwayamPrabha. Digital India. Educated India.
Hello everyone, I welcome you all to the first lecture of the course Laser Based Manufacturing. In the introductory session of this course, we have seen the importance of the lasers to be used in the manufacturing processes, and then applications of lasers in the manufacturing processes. So, in coming 20 hours, we will be studying in details about the lasers which are used in the manufacturing and their applications in further details about the process characteristics, process parameters, process mechanisms, how to achieve the optimal parameters, what are the various advanced techniques used in the laser based manufacturing domain. Well, let us begin the course with the definition of manufacturing. So, the course is laser based manufacturing. So, it is very essential for us to first understand what is the meaning of manufacturing. So, manufacturing is nothing but the transformation of raw materials into finished products or finished parts. So, these finished parts are further assembled together to get the final system or final product. So, manufacturing is transformation process, transformation of raw materials into finished part, or it can be directly the product itself. So, if the parts we are manufacturing, we have to assemble them, these parts we have to assembled, and then we are getting the final product or system. So, some of the definitions also include the design as well, design of the part, and the material selection, as part of the definition of manufacturing. So, we can consider the manufacturing as the transformation operation, design of the part, and material selection. So, as far as our course is concerned, we will be focusing more on the transformation of raw materials into the finished parts by using variety of techniques. So, one of the technique is the laser based manufacturing, the laser based or laser applied manufacturing processes. Which are these processes and how these are useful to the industry? That is the main objective of this course. Well, what do you mean by the transformation? So, what exactly we are doing in the transformation? In transformation, we are changing the shape, the change in shape of the raw material. We are changing the size of the raw material. Then in some of the processes, there is a change in microstructure as well. So, change in microstructure of the raw material. For example, in rolling operation, metal sheet rolling operation. So, there is the grain refinement during the rolling operation. We are reducing the thickness of the sheet during the rolling operation, simultaneously there is change in the microstructure as well. Then in casting operation as well, when we pour the molten metal inside the mold cavity, it get solidified, and during the process of solidification there is a change in the microstructure of that particular metal. Then there is a change or modifications in the mechanical properties. So, modification in mechanical properties as well as we can say thermal properties. So, both the properties are modified or changed during the process of transformation. We are having various finished parts or product which we are using at our domestic level in our office for your study, for your research projects, in the society as well. Various parts, various product systems we are using, and we need to manufacture them. So, if we are relying on the imported manufactured products, then we have to pay a huge cost for that. So, it is essential for every country or a nation to rely on it itself to produce the parts in-house inside the country itself. So, that is why our nation has started the Make in India initiative. So, you have to manufacture in-house and then utilize it at a affordable price and generate the employment or generate the human resource as well. So, with this it is very essential for us to go through the various advanced techniques which can be used to enhance the productivity of this manufacturing sector or the domain. Let us look at the various operations pertaining to the manufacturing. So, we can classify the manufacturing processes into two major classes or groups. So, manufacturing processes can be classified into two groups. The first set of operations are related to the processing, or we can consider or we can say these are the transformation operations, transformation processes. The transformation of material will be carried out by using these operations. And the second set of operations are related to the assembly of parts. So, assembly operations, that is the second group. In the processing or the transformation operation, again we can have various groups, that is the operations related to the shaping of raw materials, enhancement in the property of the product or the part, so enhancement of properties, so in general the material properties, and the third one is surface modifications. So, we generate the products, but later we want to modify their surfaces, that is called as the surface modifications. The surface modifications may be needed to improve the wear properties, the lubrication properties, cleaning, texture, the coatings, color, appearance. Shaping in general are done by using the casting operation, which we know very well. The casting is the shaping operation where the molten metal is casted inside a mold to get the required shape. Then forming operation, we are heating up the material above the recrystallization temperature and then we are applying the mechanical loading. So, the examples of the casting are the forging operation or the rolling operation. And the third is material removal or machining operation. So here we are using plastic shear deformation to remove the excess material from the raw material block to get the required part done. Okay. So enhancement of properties will be carried out by using the various heat treatment processes, where the hardness can be increased. So various processes are there, such as the annealing operations. As far as surface modifications, as we have seen that we have to carry out it for the cleaning purpose, for painting purpose, painting operation, then surface treatment, then texturing, coating and deposition. As far as the assembly related operation, so we can assemble the various parts of a system by carrying out two types of operation. First is the joining operations. So joining, and that joining is of the permanent type. So permanent joining, and very well known operation or the process is the welding. Welding operation, soldering and brazing. These are all operations pertaining to the joining. The next group of operation is the mechanical fastening. So mechanical fastening will be carried out by using threaded fasteners or by using the permanent fastening, that is the riveting operation. So either by using threaded parts or by using the permanent fasteners. That we call riveting operation, and these are screws, nuts and studs. Grossly we classify the manufacturing operations into transformation and assembly. As far as transformation is also considered, there are two ways, that is a conventional way of transformation and unconventional way. So in conventional mode of transformation, we are using the traditional way, such as in material removal we are using the plastic deformation by contact type of processes such as turning, milling, all these processes. So we are using mechanical energy to remove the material in the machining operation. But many a times it is not possible to apply the contact type of tool for high strain materials, for delicate parts. So in these scenarios we have to think for some unconventional way of processing it. So there are various modes of carrying out the unconventional machining operations, and these are based upon the thermal energy based operations or chemical energy based operations or ultrasonic based operations or the hydraulic energy based operations. So as far as the thermal energy based operations are widely being applied in the industry, and these are electric discharge based operations that we call the EDM, electric discharge machining. We can use high speed electrons, that is electron beam machining, it is called as EBM. Then plasma arc based machining, and the last one is the laser based machining. So, as we have seen that lasers have many advantages over the other manufacturing processes. In our previous lectures also we have seen that the lasers are not only useful in the machining operations in unconventional way, they are also very much useful in forming operation in unconventional way, that we call the laser bending or laser forming. Lasers are also used for the surface modification, so that is the laser shock pinning and laser texturing as well. Lasers are also used for coating operation. So, laser based cladding we can do, or laser based deposition is also possible. So, lasers are not only used in transformation operation, they are also used in joining operation, that is the laser welding. Well, among all these thermal energy based processes, today the laser beam based manufacturing is finding a very prominent applications in the industry. The reasons are quite obvious. So, lasers are providing us a very high power density beam, and that beam size is very small. So, at a very small focal size on the workpiece or a part, we can have a very high power density generation, and due to that we can ablate or we can carry out the intended operation. It may be just melting operation or vaporization operation. So, laser based manufacturing is finding in that way the prominent application in the industry, due to the reason, that is generation of very high power density, So, how this very high power density is achieved in lasers? So, this is being achieved by having a highly coherent beam. So, highly coherent beam of radiation, highly coherent beam of radiations, and these radiations are the electromagnetic radiations. So, these are the electromagnetic radiations. Then the next characteristics is that the beam is monochromatic. And it has the ability to focus on very small area. Well, there is another usefulness of the laser beam, that we can carry it at the intended location. So, the conveyance of laser beam. The conveyance of laser beam is easy with all the optics or the instrumentation available. Then you will say that these electromagnetic radiations are also available in the general lights that we do have, or general source of lights. The major source of light is sunlight. So, we are having the sunlight, we are having all these fluorescent tubes or the bulbs, or we are having a very simple incandescent bulb which we are using for illumination purpose mostly. So, these source of lights are generating the rays of electromagnetic radiations, but these are not coherent. So, the sunlight or the bulb or tube that we do have, sunlight or the bulb or tube that we used in our domestic application. So, these are also generating the rays of light, rays of electromagnetic radiation. But these electromagnetic radiations are non-coherent. They are non-directional. They are scattered, random. And these electromagnetic waves are having different wavelengths. They are having different wavelengths. It's a mixture of rays with different wavelengths. So, they are serving the purpose, we are getting the illumination, we can see the objects. So, that is serving the purpose. But when we talk about carrying out the manufacturing operation where we need to cut the bond between the molecules of a very high strength material, then we have to apply the high level of energy, high power density. So, to create that high power density, we need to have a monochromatic beam of the electromagnetic radiation, and it should have almost same wavelength, and it should be in a one direction itself, that is in one direction all the rays of electromagnetic waves should pass, they should travel in only one direction. So, that we call the laser. So, laser, to all you know, is that is a light amplification by stimulated emission of radiation. So, as you all know, the long form of laser is a light amplification by stimulated emission of radiation. So, we are having radiation, but that radiation is generated based upon the stimulated emission, and due to that we are getting amplified light. So, the high power light which is focused on a very small area, a very small diameter beam, and due to that very small diameter beam, the density is getting increased, the power density is getting increased, and due to that high density power we can carry out the intended operation, say melting operation or vaporization operation, or even the forming operation, just heating operation that we can carry out. So, what do you mean by this the coherent or the incoherent? So, if suppose we consider an ordinary light, so if you consider an ordinary light, so how this waves would be in the ordinary light. So, let us consider along the x and y. So, if suppose we are having on one wave of this, then the second wave or the another wave of radiation may not be starting from the origin, it will start from some other direction, or we can have another wave which is in this wave. So, this we can call as the incoherent waves of ordinary light. And if you draw, or if you want to just look at the waves in the laser device, then you can have an idea like the laser is having the electromagnetic waves which are almost having the same wavelength. So, here you can consider in the same way or in this way. So, this we can say about the laser. So, let us summarize the laser characteristic here. So, lasers are having the waves which are directional, they are consistent, all the waves are having same wavelength, which is very important. And the rays are highly parallel to each other. So, they are parallel to each other, the waves are parallel to each other. Due to all these features, lasers are widely being applied in the industry. Fine, let us look at what are the various applications of lasers in the manufacturing. So, we will just have an overview of the applications of lasers in manufacturing. So, lasers are used at product development stage. So, how they are used in product development stage? So, now all we are very much fascinated about the 3D printing or the additive manufacturing technology. So, in 3D printing we are using lasers to manufacture or to fabricate the parts at a very rapid way. So, during the process of the product development, it is very essential for us to generate the parts so that we can visualize or we can realize the shape and size of the parts at very early stage of its development. So, there we are using laser based 3D printing techniques to realize the parts in the product development. So, one application is product development. The second application is the actual production, the production processes. So, production operation or production processes. So, variety of production processes that we have seen, such as the material removal, that is ablation, then cutting operations, we are having forming operations, welding operations. So, all these are the production processes where lasers are widely being used. Third is the repair. Consider repair of some parts of the machine or the machine tool need to be carried out. Repair of machine parts or tools. Repair, and we can also consider that as the correction. Repair and correction. Then in the manufacturing industry, we are using lasers for the measurement. Measurement of length, or you can consider the size, surface roughness, surface quality. Then in manufacturing, we are using the lasers for guidance as well in material handling. The automated industries are equipped with lasers with for the conveyance operation, such as the automated guided vehicles. So, these automated guided vehicles are equipped with laser based sensors which can guide them to maneuver or to convey the parts on the shop floor. Now, if you look at the production processes, there are various other applications of the lasers, and these are marking operation. So, if you just look at the various products which are there with you, particularly the biomedical products, it is very essential to mark or to have the unique identity code on the products, and these parts which are in working condition. So, they are being applied with heat, humidity, dirt or friction. So, during this application of such factors, this identification number should not get spoiled. So, laser based techniques are used to manufacture or to mark the unique identity number on the products or parts. Then we are having surface texturing. Surface texturing. So, we can generate various patterns or textures on the surface of parts and products, and the purpose is for improvement in its grip, improvement, its wear property improvement, wear rates improvement. Then we can even modify the optical properties of the surface, optical properties, and the load capacity as well. So, surface texturing of meso size or micro size is being carried out by using the lasers. The very simple example is the texturing of the tool rake surface. So, the students with a background from mechanical or production engineering will understand that on the rake surface of the cutting tool, it is now applied the lasers to manufacture the dimples or serrations to improve the tool performance, so that we can break the chips at convenience. Moreover, the bio implants, the implants which we are putting up, are given with the surface roughness. The surfaces are made purposefully rough with a certain RA value, certain roughness value. Why this roughness is given on the implants? So that the new tissues can grow on them, or these implants can get very well adjusted with the bones, so that the bones can hold the implants firmly and they grow over the implants. So, this roughness is deliberately provided on the bio implants to grow the tissues and to have firm holding of bones with the implants. We are also having application in ablation. In ablation, we are vaporizing the material, and by vaporizing the material, we can generate the required features on the work part. So, this ablation can further be considered as the cutting operation, or we can consider these as the drilling operation, engraving operation, so what are the advantage of all these things? Here we are getting very finer cuts we can achieve, very small heat affected zones, during the laser based ablation. So, we will be seeing all these operations in detail in the next weeks. Then we are having applications of lasers in welding. Welding is having a very important application of lasers in the perspective of joining dissimilar materials and joining of thin materials. Well, we will also be studying the welding operation in the next weeks. In addition to the welding operation, lasers are also being used in material forming. Here we are applying the laser to heat up the material above the recrystallization temperature and below the melting point temperature, and that is generating the thermal stresses during the cooling operation. These thermal stresses will help us to deform the material. So, deformation of the material. So, various materials which are difficult to form, such as the magnesium. So, this magnesium material can easily be formed by using the laser based forming operation. And the last is the additive manufacturing. So, laser based processes are used. So, additive manufacturing also nowadays having applications of lasers. We will be studying these all operations in detail. We are also using lasers to measure the surface topography or to analyze the surface topography. In the measurement application of lasers. So, thus lasers are not only used in the production processes of a product life cycle. These are used right from the start in product development, production processes, product inspection, quality control, and then to enhance the productivity by helping the material handling as well. So, with this I would like to conclude my introduction lecture to this course, laser based manufacturing. In the coming lecture we will see how the lasers are getting produced, what is the mechanism of laser production, the principle of operation, and what are the various process characteristics of the laser. Okay, till then, goodbye. Thank you very much for watching this video.